Thank you all of you for showing up today and on our continuing cold weather day kind of a situation. And that's kind of what partly the theme that I'm going to talk about today is actually kind of separating the difference between weather and climate. And it's also going to be a bit of a call to arms, if you will. And you might find parts of this talk a bit depressing, but maybe it's me that's a little depressed these days about the action that in answer to the question, it's not going away. All the indicators are that the climate is continuing to change, but the problem is policymakers and government are not doing enough. So that's if you want to leave now, you've heard the gist of the talk. So what I'd like to talk about then is both a little bit about weather and climate science, a little bit about potential climate impacts here in Edmonton, then switch gears a little bit and talk a bit about climate policy and politics, and then sort of finish off with things that we can all do to sort of help the situation along. So climate change is quite a complex and creeping issue, and in many ways it's like trying to build a huge house, and there's scientific issues at the bottom, there's how we use energy and fossil fuels, there's societal implications, governance, law, and again, there's so many dimensions to climate change that we're trying to build this house to deal with it, if you will, but there's so many pieces and nobody's really in charge, and it's a bit of a mishmash in terms of how we're constructing this response to climate change. And it also isn't quite in our face yet. We don't actually experience as directly as many countries are starting to experience it. So it's easy to kind of let it slip from our radar screen. Well, what I'd like to start first then is talk a bit about the difference in weather and climate science. And it's sort of like this cartoon too. I mean, if you've got firm beliefs about this, you think, ooh, it's snowing, global warming isn't real. And some people sort of cling to that as, well, that's my belief system. And so every weather event I see, it either supports my view or whatever. And that's an unfortunate situation. And sometimes because of our evolutionary past, we don't really pay attention until something is really in our face. Like this is from one of the movies, 10,000 Years BC, you know, where the Smilodon is right in the guy's face. And because of our history, then we don't really pay attention to something until it's really in our face. And the weather is different then. So weather refers to short-term changes in air temperature, precipitation, all these factors at a given place and at a given time. And it's very highly variable, as we've seen this winter with our weather. It's quite variable. Climate, on the other hand, is what we can think of as average weather over longer decadal sort of time periods. So it's the average temperature, the average precipitation, and so on. And climate can be relatively stable for sort of thousands of years, which it really was in Alberta here for several thousands of years, but it's now starting to change. Weather then is like this in Edmonton. So this is just some charts of precipitation over the last year in Edmonton, and this is the last, couple of weeks or 2 months here. And again, that's a reflection then of fluctuations in precipitation over the last little while. And in Edmonton, we tend to get most of our precipitation in the sort of July summertime. But you can see this year with all the snow we had obviously quite a lot of precipitation in the winter, which was a little unusual. And also weather events are like this forecast here for the next coming, you'll be encouraged to see the forecast is for a warming, getting closer to normal sort of temperatures, so that's encouraging. But weather then is like single events, short-term sort of things that are going on. Climate, on the other hand, is this long-term averages. And this, for example, is the long-term precipitation now for Edmonton from about 1940. And you can see it bubbles around up and down a bit. And it's been pretty constant at around 500 millimeters of rain and snow combined since the 1940s. And you can see there's variability, but this red line shows the sort of trend overall has been pretty close to that on average. But you can also see in the last decade, we're starting to notice a little bit of a downward trend in terms of the amount of precipitation we're getting in Edmonton. Likewise, the average temperature in Edmonton has been, this I should say too, is the average temperature from winter, summer, you know, spring, fall, summer, daytime, nighttime. You'd be discouraged to know it's only about 2 degrees was the average temperature, at least back in 1940. And now what we seem to be having is a general rise in temperature. So the actual temperature now is more like +6 or 7 in Edmonton. So we've actually seen about a 4 or 5 degree increase in average temperature now in Edmonton. And again, it's thought that this is probably a reflection of the climate changing and global warming. It also gives rise, the climate gives rise to the kind of ecosystem that we live in and anybody lives in. And so, for example, this particular climate gives gives rise to our aspen parkland kind of ecosystem here in Alberta, or in Edmonton rather. Well, the climate itself is quite a complex system, and it has a number of components related to the ice that we call the cryosphere, related to the atmosphere, the oceans, the hydrosphere. It even relates to the geology, and it's actually quite a complex interaction of things that actually give rise to the climate. But increasingly, the anthrosphere is what we call human activities. It's actually becoming a stronger determinant in the climate system because we are kind of monkeying with it. One of the most important components, though, I wanted to touch on in the climate system is the greenhouse effect, and we probably should call this the natural greenhouse effect, because this has operated for several billions of years, in which incoming solar radiation, some of it gets bounced off the atmosphere, some penetrates the atmosphere, is absorbed by the Earth, and then it bounces back out as infrared radiation, as heat radiation. And then sometimes it gets trapped by these greenhouse gases then, and it actually keeps the planet a bit warm. And essentially then, any increase in greenhouse gases tends to be like a thermostat in your house, where it tends to warm the planet up, and if you turn greenhouse gases down, it tends to cool the planet down. And that's actually operated for some hundreds of millions to billions of years. This thermostat has been operating, and these are the major greenhouse gases here. So we're going to have this natural greenhouse effect where incoming solar radiation, and if we didn't have any greenhouse gases, if we had a negligible atmosphere, most of this radiation would just bounce back into space, and the actual average temperature on the planet would be -18, and probably wouldn't support a heck of a lot of life. The fact, though, that we do have these greenhouse gases in the atmosphere has essentially meant that we have a warming or a boosting effect of about 33 degrees, so that the average temperature now on the planet is about +15. And again, that means everything from the poles to the equator, daytime, nighttime, summer, that's about 15 degrees is the average temperature. Now, this has changed in the geologic past. We've actually had higher concentrations of greenhouse gases, and the temperature's been much higher. But the problem is, we're sort of putting the greenhouse, I call it putting the greenhouse effect on steroids. We're sort of pumping up the volume, if you will. And it sort of starts, an analogy I use with my students, it's sort of like a pool table where we have a natural greenhouse effect, but human activities are sort of like the cue ball, where we're adding more greenhouse gases to the system. About 50 million tons a year we're adding incrementally to the natural greenhouse effect. This in turn is leading to higher concentrations of CO2 in the atmosphere. And for the last 650,000 years, it was around 180 to 280 parts per million. And now it's at 390 parts per million and rising by about 2 or 3 parts per million every year, because we're putting the greenhouse effect on natural greenhouse effect on steroids, if you will. And again, a reminder that anytime we increase the concentrations in the atmosphere warms up, and if we turn them back, it tends to cool things down a bit. But again, concentrations leads to a warming effect then. So the planet, the atmosphere starts to warm up a little bit. And so far, it's warmed up by just a little less than 1 degree since 1885. And you may think, well, what's the big deal? And I'll try to explain that in a second. This also then leads to global warming. So the atmosphere starts to warm abnormally beyond what it usually does. And this essentially is sort of my analogy of putting the greenhouse effect on steroids. It starts to get warmer and warmer, if you will. But that's not the end of the story, because global warming then leads to climate changes. So the climate starts to be affected by the atmosphere warming up. And that includes things like rising temperature of the ice, the land, the ocean. The planet's trying to cool itself down, so that extra heat, it's throwing some of the extra heat in the oceans. It throws some extra heat in the ice fields and it's trying to maintain an equilibrium, if you will. Extreme weather events are starting to become more prevalent. We're starting to see changes to the water cycle, because when the atmosphere warms up, it can hold more moisture. So that means our whole water cycle starts to go a little faster. Sea level is starting to rise slowly so far, but it's also becoming more acidic, because again, the planet is trying to take this extra CO2 and, oh my God, what do I do with it? So it's going to dump some extra CO2 in the oceans. The land and plants are taking up some extra CO2, but it's not a complete process in that sense. And again, the ice sheets are taking up some of that extra heat, and they're starting to melt then. And that's not the end of the story, because again, it's like on your pool table, you're breaking these balls and you have a rippling effect of cause and effect. This then is causing impacts to our human and natural ecosystems, and this is leading then to the need to adapt to a changing climate. So that's kind of putting the greenhouse effect on steroids. That's my story. And again, you may think what's the big deal about 0.8 degrees? That sounds pretty small. But when we had the ice ages here over Alberta, we had 20,000 years ago, and we had about 2 kilometers of ice where we're standing now. The average temperature on Earth was about, plus 8 degrees or so. And it actually warmed up since the glaciers melted. Over 10,000 years, the planet warmed up, and we're in an interglacial period. Things got kind of nice, and we actually warmed up by about 7 or 8 degrees on the plus side, if you will. But keep in mind, that took 10,000 years to warm up that plus 7 degrees or so. But now we've actually increased the temperature by almost a degree in 100 years. So this is pretty fast rate, and the forecast is if we continue on this pace of putting extra greenhouse gases, increasing the steroid effect, if you will, that will actually increase the planet's temperature by about 6 or 7 degrees on the positive side now, over 100 or 200 years compared to, the same amount during the glacial times in 10,000 years. So that's a very rapid sort of rate of average global warming. So I wanted to turn now and talk about the climate, or potential climate impacts in Edmonton, and are we seeing any yet? And before we do that, we actually have to look at, it's important to look at other places around the world where impacts are more pronounced. Places like even in Canada's north now, we're seeing a lot of warming in the north, and the Inuit people are facing new dangers. They take their snow machines out to go hunting, and traditional knowledge says that at a certain time the ice is safe, so off they go in their snow machines. And there have been cases now where they actually drop through the ice because the ice is melting and they weren't expecting it, and people have drowned, sort of thing. We're also seeing collapsing buildings in Russia because, again, the whole Arctic Circle is getting warmer. So all this permafrost, when these buildings were built in the Soviet era of the 50s and 60s, is now getting undermined because the permafrost is melting, so the structural integrity of the building just starts to collapse. We're also seeing in coastal Alaska regions where even with modest sea level rises, the coastal erosion is starting to sort of accelerate and knock down buildings. And in particularly in countries like small island states in the South Pacific. This is Tuvalu. This is just an aerial photograph of it. It's a small country that's essentially around a coral atoll, about 10,000 or 50,000 people. But again, they're only about this far off a sea level, and the sea level is starting to rise. And there's a distinct possibility that Tuvalu and many of these countries will become climate refugees, and essentially they'll have to find another place to live. And in fact, they're negotiating now with New Zealand and some countries to say, essentially, if this gets pretty bad, can we essentially move the whole country to New Zealand, or at least the population? So that's pretty severe. But what we are starting to see again globally is the sort of proportion of really severe rainfall and snowfall events, precipitation, are starting to decrease in many places around the world. So this isn't, again, the average rainfall. This is really heavy, really heavy events that start to happen. And any place you see these little pluses, that means this sort of really heavy precipitation events are increasing, and the minus signs are where it's decreasing. But you can see around the world, a lot of places are seeing these very intense. And again, this is a function of as you speed up the temperature, you heat up the atmosphere can hold more water, the water cycle starts to increase faster and faster, and so you get more precipitation events. So it's possible that, again, precipitation isn't just rain. Of course, as we know, it also comes in the form of snow. And it is possible that we may start to see more problems in this area of more intense snowfalls, for example. And this is still sort of speculative, but when precipitation comes, as I said, it can come as rain or snow in our part of the country, can't it? So again, for the city, it's possible that in terms of snow removal, this might become a continuing problem or cost for the city. Who would have thought that these snow rakes would have been, a thing that were important, because people that didn't actually remove the snow, you started to get this ice buildup on roofs, and this led to ice dams building up, and if you didn't have good insulation in your house, it led to melting of the ice, and in fact, in some places, people were getting waterfalls in their living room, because it was setting off this sort of cascading series of problems. It's also possible, not to scare you, but you may want to, if we get a very rapid melt of all this snow that we've had, it's possible that you start to get water in basements again. But again, this is just, possibilities, and I don't want to say this is a for sure. It's just, as you sort of heat the whole atmosphere up, these things might become, statistically more common than we've seen them before. And again, it's not just winter time, but also in the summertime. We've obviously seen flooding in Edmonton in 2004. West Edmonton Mall saw flooding in 2008 from a hailstorm. I think the city of Edmonton, I got from their website, has actually a flood sort of program in place following the 2004 event. And again, it's not to say that each one of these was caused by global warming. That's not the case at all. It's really just saying the frequency of these intense flooding events in the summer might become more prevalent. And you may want to check your insurance. In fact, I checked with our insurance agent just recently, and I was surprised to find that we're covered for most of these sudden events. But for example, if there's a flood and the water comes in your window or comes in a crack in your foundation, you're not covered because you were supposed to have looked after that sort of thing. So it may be good to check your insurance coverage. And again, somewhat ironically, it may mean that even if we're having more extreme precipitation events either in the winter or the summer, it may still mean that our total precipitation may actually still be going down, because it may be the same amount of precipitation, it's just coming at really intense sort of periods, if you will. And that's a possibility as well. Well, the number of forest fires are also increasing around North America because, as again, you heat the atmosphere up, you have more lightning strikes, the forest tends to be drier. So again, you sort of see a general trend upwards in fires. And again, it's possible then that we may see more summer smoke like we saw last summer, where the smoke drifts in from, where was the fires in BC somewhere last year, and for people like myself that have asthma, that could cause more problems. And I was stupid last year. I went out bicycling during one of these episodes, and I paid for it for days afterwards, which is a dumb thing to do. And also heat waves seem to be increasing. This again is sort of a chart of sort of temperature extremes in Europe since 1800, and you can sort of see there are extremes but then there's sort of cooler times, warmer, cooler, warmer, cooler. The average trend is sort of like that. But see what happens in the 1970s onward, the baseline started to increase. And then in 2003, they had an unprecedented heat wave in Europe that actually killed some 70,000 people. And this, again, was mostly low-income seniors and people that couldn't afford air conditioning that sort of bore the brunt of it. And some studies have actually demonstrated that although we can't say that this heat event was entirely due to climate change, there was a sort of a study that was done that suggested that at least a third of those deaths, the probability of an extra third, was due then to global warming. And again, as the water changes, as the climate starts to change in Alberta, you can see this is kind of our current ecosystems, with our aspen parkland and our grassland and so on. And by about 2050, if this drying trend continues, we may well be in Edmonton here have a climate more like Lethbridge in terms of grassland, and Lethbridge may become a little bit more like Montana or something like that. And so this may actually have a boon to agriculture in some parts of the province. Some models suggest agriculture could actually increase, at least if you're in the northern part of the province. But again, if you're in the southern part of the province and you depend on irrigation, for agriculture, water could become an issue. And we're also seeing, in terms of drought stressing on different varieties of trees, this suggested that in the parkland area we're also starting to see, stressed trees, and that this red area is where we may see stressed trees in the future because of, again, as the climate dries out. But again, I think already we're starting to see in the city here, a lot of the birch trees actually died about 5 years or so ago. Certainly in our neighborhood, couldn't find any live ones. And the poplar tend to be a little more resilient, but I took this photograph near Westlock, and you can see some of these poplar were also drought stressed and were dying. And in fact, last year, some of the spruce trees, you may have noticed, were getting, it's a little hard to see, but they have the red dying ends of them as well. And that again is sort of an indication of drought stress. And again, if you're doing a major landscaping, you really want to start thinking about buying a drought resistant species, because you put the wrong species in and they could be dead in a year, and you could spend $10,000 or $20,000 on landscaping, and you're sort of in trouble. Trees also get very vulnerable to insects when you have prolonged droughts, so that sort of does a double whammy to trees. And you may want to check then with a reputable nursery. I know the city of Edmonton, for example, I think is planting a lot of bur oak, which are very resistant to drought, I think, and that's sort of a thing we can all take advantage of. Ironically as well, there are indications that as the things dry up, if we have a lot of dry summers, for example, you can start to get foundations cracking because the soil essentially dries out, and it's a bit like the permafrost situation in Russia, where suddenly the structural integrity of your house kind of gets eroded because the soil is shrinking so much. And this advice from the University of Missouri was you should, and again they're having some droughts in Missouri as well, they're suggesting you may want, in fact, water your foundation if you have a very dry year. And I think there was some anecdotal evidence even in Edmonton last year that maybe some people were starting to have foundation problems. And ironically, you could also be faced with water-damaged foundations if we have these intense, summer rainstorms. Well, let's talk about climate policy and politics quickly then. And this cartoon, I think, kind of summarizes, I think, where we're at. Unfortunately, we've run out of gas. Things are not going well in terms of what they should be. I was involved with the climate negotiations about in the early 2000s, and they've actually gone through several phases. You can think of them as waves of activity, where the Framework Convention was agreed to in the 90s. There was a broad, media announcement, and then they quickly realized that that wasn't going to be enough, that the scientific community was saying you got to do more. So they negotiated the Kyoto Protocol, and that was announced with great fanfare. And a few years later, the scientists said, that's not enough, you got to negotiate something else. And I think this is going to be the paradigm for decades to come, is you'll see multiple sort of waves of negotiations to try to deal with this issue. And right now, the economic downturn has kind of made people a little disinterested in doing anything that'll hurt their economies, and no one wants to commit to action without the largest emitter, the United States, doing something. And that's a real problem now, because the United States and China are what we might think of as Keystone countries. Remember, this is the arches the Romans used to build, and this was called a keystone, which essentially gave the whole arch structural integrity. And if you didn't have the keystone, the whole thing would collapse down. And that's about where they're at right now, because there's about 15 countries that are 80% of the global greenhouse gas emissions. And unless you get these 15 all helping to build the arch, and unless you get the United States and China to do something, it won't stand up. But actually, China and India have actually agreed that they'll take on some kind of intensity targets. But right now, it's the United States that is just intransigent, and the president is into paralysis now. He can't do anything on the environment. The Republicans are pushing back hard on any kind of environmental initiative, and the grand old party is also again, really pushing hard and really anti-climate science, and it's just a bad situation there. But again, the ramifications for the rest of the world are nobody wants to go ahead unless the U.S. as a keystone player kind of gets on board, because in fact the United States and China together are about 40% of the global greenhouse gas emissions. So if you don't get those guys doing something, everybody starts to think, well, what does this matter? And there's a lot of policy pieces, and again, it's like putting together, these are just individual issues that are being negotiated now, and we don't need to worry about the details. Some of them have happy smiley faces where they're making progress, but you can see there's a lot of lightning bolts where there's still a lot of, and on the backdrop to all of this is the economic downturn and mistrust that the United States will, even if you get them to agree to something at the UN, will they actually follow through with it, which they actually didn't do in the Kyoto round of negotiations. Well, what is Canada doing then in terms of Canada? The Canadian government has multiple policies on greenhouse gases over the years. The current Conservatives are trying to limit the use of coal-fired power plants, so they're actually setting a regulatory limit that would be the same as a natural gas combined cycle. But I'm not sure, I give it a sort of less than 50-50 probability. So sometimes when governments announce they're going to do something, you have to sort of wait and see if it actually transpires, because a lot of stuff gets announced that never actually gets adopted. And this is just the emissions of Canada are showing some signs of maybe starting to flatten out a little bit there. The federal government is also committed, or at least they were in 2007, to phasing out the old style incandescent bulbs and making that a regulatory requirement that you simply couldn't buy those kind of bulbs anymore. And again, we'll see if, I think that's still on track to happen, unless somebody knows. Okay. The other thing they're not doing, unfortunately, though, is putting a price on carbon. And that this is a real problem, because every time we pull up to the pump and buy gas, it's not just the CO2 that comes out your tailpipe, but it's the whole chain of delivery involves CO2 emissions. And even our stuff that we buy, you may think a computer doesn't have any CO2, but in fact it does, because in the manufacturing of that computer, this little device here, it all took CO2 to build those things. And the idea of a carbon charge then is to get us to buy, you know, because we're not getting a freebie anymore, it's to make us more green consumers, if you will. Well, the Alberta government actually did put an emission intensity cap in place for large industrial emitters. They actually do have a cap. Some of them are paying into a fund if they can't meet the cap. But the big one here for Alberta is this carbon capture and storage kind of option, and the government has committed $2 billion for it. But I saw last month or so, they sort of said the spending profile is going to be a little slower, you know, and they're not making as much progress at the individual projects as they had hoped. So that's going a little bit slow. Well, so if we say, well, how has the policy that we put in place, is it making an effect? Are we making any progress on the issue? And if we look at the emissions of CO2, you can see here's when the Kyoto Protocol was adopted, 2007. There was a little bit of maybe a downturn, but then suddenly you see everything's been up since then. This absolute emissions are continuing to rise. We had a little bit of a downturn with the recession the last couple of years, but it's forecasted that once the recession's over, it'll just keep going upwards again. So emissions they've just been continuing upwards, even with Kyoto. The Arctic sea ice extent, you probably saw these pictures of 1979 versus 2007, where again, about half of the Arctic sea ice is contracting every year. And again, this graph just shows there's a lot of variability on a year-to-year basis, but again, the downward trend is like that. And again, the Kyoto Protocol has essentially had no impact on melting ice in the Arctic. We've also had increasing heat waves. This is the one in Russia just last summer, where their average temperature was 8 degrees above the normal. It was sort of the hottest in 130 years. This led to droughts, crop failure, the price of wheat went up. There was thousands of people died, homeless. A lot of the forest fires around Moscow caught fire and so on. And ironically, as people were in Moscow were trying to escape the heat, many people actually died from vodka-induced drownings, if you can believe that. Only the Russians. But yeah, apparently they died because they were drunk and trying to cool off, and who knew? But again, we're not saying that the Moscow heat wave was entirely due to climate change, but again, these kind of things are starting to happen more frequently. Well, let's turn to the last topic, and then things we can all do to reduce climate change and help the problem. And this is not going to be easy. It's a bit like this cartoon. It's time we change the way we do business. Well, let's plant a tree, carbon offsets. It'll help the planet, but you know, you're not stopping your pollution. So pretty soon the tree dies. Well, that's the thought that counts, and maybe we'll put a plastic tree in next time, kind of thing. And it's not going to be, although there's a lot of good programs like the City of Edmonton's offering and so on, it's not going to be an easy haul. But we have to make a start, and we have to do a makeover, if you like, on our own lives. And you sort of say, well, I'm willing to do that. How do I do that? I think what you might do is sort of start with the small, easy-to-do things, and then work your way up to the harder-to-do things. And I'll just kind of give you some examples. The first thing you do is stop buying bottled water, because people don't, and Timmy's, because people don't realize, you bottled water people in the front, that actually to produce that plastic for the bottled water, in the United States at least, there's 26 billion liters of this plastic water that was produced, but it actually produces 2.5 million tons of CO2 just to produce the container. You know, that I didn't mean to put you guys on the spot, I apologize. But it is an issue, and the same with Timmy's cups. You know, they take CO2 to produce those cups, and then they end up in the landfill site as well. So buy a Go Mug and use it is the easiest thing you can obviously do. But again, you know, in terms of your consumer spending, every time you pull your wallet out to buy something, try to think mindfully that there is a causal effect of CO2 every time we buy things. Do we really need all the stuff we buy? Now the harder to do ones are things like your furnace replacement or the white appliances, low flush toilets. These kind of cost in the thousands of dollar range, and they're the things that you can take advantage of. Many of this, well, like the city I know has a program, used to have the program. I was fortunate to be able to take advantage of the cities and the province and the federal government's funding. We put a new furnace in our house a few years ago, and that was really great. But again, you want to do these if you're doing a renovation on your home. That's the time to kind of do these kind of, things that are thousands of dollars. It's the harder to do ones are when you get to your transportation, and this is kind of be in the $20,000 to $40,000 range, where in this graph here, you sort of want to be down on this end if you can in terms of your transportation options. And there's actually a lot of carbon benefits, obviously, by moving down at this end of the transportation scale. There's a lot of health benefits because you're getting more exercise, particularly if you're in this realm. And a lot of wallet benefits, I call it, because it costs you a heck of a lot of money, especially with the price of gas being what it is now. And just as an example, and I don't mean to, pretend to be a paragon of environmental rightness, if you will, but this was our family in 1990s and the early 2000s. We actually had 2 vehicles. Our family was a bit bigger at that time. But since then, we become empty nesters, and then we decided that we need to get a new vehicle. But we actually decided not to get 2 new vehicles. We're pretty sure we could get by with 1 vehicle. So we actually bought the Bullet and spent a little more on a Prius, so it's the most fuel-efficient vehicle we can get. And I actually managed to ride my bicycles throughout the year now, and the city's actually got pretty good bike paths now and things, so I'm actually able to ride year-round. So it actually works pretty well. And again, it's sort of brought me down and our family down in kind of this range of the transportation realm. But the really hardest thing, I think, to do is where you live and what kind of home you buy. For most of us, this is like a $250,000 to several $1 million purchase, and it's the kind of thing that we don't buy too many houses ourselves, maybe 25 years, but the kind of house you buy in terms of, is it a very efficient house, energy efficient house, or do you have kind of a big sprawling McMansion kind of thing with large floor area that takes a lot of energy to heat, and so on. This is probably your most important decision then in terms of the environment. And it's also then where you live, because it's not just the kind of house you buy, but if you live out in the suburbs, you're adding those extra emissions by driving in town. So the closer you can live, to where you work and so on is much better. And don't forget too, if you're buying a second cottage or a home, we just actually recently bought this cottage with our family members in northern Manitoba, and I'm trying to convince our partners to make it more environmentally friendly and so on. But before we bought it, we actually did some research on lake levels in northern Manitoba, because we actually started looking for a cottage in around Alberta here. But when you look at what you can get, it's like $500,000 to start. And I'm not sure the lakes, not to scare anybody that has a lake cottage in Alberta, but those lake levels in Alberta and the Alberta lakes, I think, are going to be subject to some fluctuation. And I wasn't confident then that I wanted to buy spend that much money and then potentially not have a lakefront cottage. So I actually checked, and the Manitoba government actually had good resources, and that it appeared that at this particular lake in Manitoba, the water hadn't fluctuated very much. So I was part of our decision. But our North American lifestyle and consumption habits are really not sustainable. And we're going to have to make more or pay more for this lifestyle, or we're going to have to make changes, or we're going to have to simplify things, because right now our carbon footprint for the entire developed world is pretty big. And the developing world has a relatively smaller carbon footprint, but they would like to have a big carbon footprint, not that per se, but they would like all the stuff that we have in our Western world as well. And again, many places like in China and India, there's a growing middle class. They're making more money and they want the nicer things in life, and who can blame them? So again, we've got this sort of a problem. And in terms of small numbers can add up. So this is going to be a mixed message slide. It says, well, here's Canada's current greenhouse gas emissions, about 770 megatons. And if we all changed just change one light bulb, we'd actually make an 8 megaton reduction, which is hard to see at this scale. If we all changed all of our light bulbs to the compact fluorescent light bulbs, that would actually bring us down this far. If we all bought Prius cars, we'd be down to this level here, so we'd make about a 24 megaton reduction. If we all changed all of our bulbs and we all bought Priuses, we'd be down to this level here. And you'd say that's not a bad start. That's 32 million tons. However, the bad news is that scientists say this is about the level we need to be by 2050. And keep in mind, we actually haven't delivered this part yet. And scientists further say that by the end of the century, we need to be 80% reduction. So this is all good stuff, and we need to do it, but this is a big issue when you think about I guess the point too is that we can all do things as consumers, and this is just a pie chart of where emissions are coming from. So you can see us residential people, we're part of that 15%, we're a little bit of this transportation as well, but we can't do it alone. You know, if we did everything we could do, we still wouldn't be far enough along. So government needs to take stronger policy action. And they need to then put stronger carbon pricing, for example, in place for industry and so on. And I think we need to speak up as well and get mad. This is sort of, I'm reverting back to my 60s radicalism here to get you a little bit mad about this issue because it's not going well. And I think it's important that we do those things as we talked about, and the city has programs that they're introducing. But we also need to talk about it with our friends and relatives and sort of say, you know, global warming is real. And I got into a fight with my nephew at Christmas about, he works for the oil patch, and he was, global warming is a bunch of crap, and blah, blah, blah. So I had to give him a lecture and say, what are you talking about? So sometimes you have to do that. You have to get a little bit mad and give people a lecture. You maybe need to join a protest if there's one. You have to express your views at the ballot box. If you don't think the government's doing enough, you need to start writing letters, sending emails, whatever, text, because we need to get broader engagement, and we need to send the signal to politicians that they need to do more. And then just finally to wrap it up, this has been a bit of a gloomy talk, I'm afraid, but I really do think it's a bit of a call to action as well, call to arms, and that I think there are some rays of hopes in this. And certainly when I teach students at MacEwan, I do sense that the younger generation actually does care about this issue quite a lot. And they also have the technology savvy, I think, to maybe start to organize grassroots level kind of action. And in fact, this was is thought to have been the reason for the the uprisings in the Middle East now, is because young people were texting away and could mobilize action, you know, in a very short amount of time. I also think that my generation, the baby boomers, are starting to think about the legacy we're leaving to our children and grandchildren, and I think that'll be a motivator as well to say, well, Jesus, it's kind of left a mess here, and I don't want my kids and grandchildren to inherit that mess. And the final one slide here too is also a reminder that this is an intergenerational issue. This is not going to be one that's solved in my generation or even the younger people's generation. This is going to probably take 50 years of effort, I think, to actually get close to solving it. So each generation is going to have to kind of do something to advance the problem. And that's it. Thank you very much. And if there's time for questions, I'm happy to take them.